Guys, so now moving on, we'll learn about how to find the number of protons, electrons and neutrons in an atom. So for that, what you actually have to do, like for example, I take an element here, Na for sodium. I take here sodium as element. You can take any element, and the examiner will also ask you some these kind of questions. So if I take sodium Na over here, you know that its atomic number or proton number is 11 and its mass number or nucleon number is 23. 23 it is known as relative atomic mass number or nucleon number. The examiner can use all these three words. And over here 11, you can say that it is your atomic number or proton number of the element sodium. And you must know that this mass number is usually bigger than the atomic number. Why? Because the mass number is actually the sum of protons and neutrons inside the nucleus of an atom. So what does this mass number includes? It includes protons and neutrons both. However, on the other side, this atomic number only tells us about the number of protons inside the nucleus of an atom. So this proton or atomic number only tells us about the protons present inside the nucleus of the atom. So it's clear that it's obvious that 23 here is bigger. Why this mass number is always bigger than this atomic proton number? Because this mass number tells us the sum of proton and neutron, whereas this atomic number or proton number only tells us about the number of protons present inside the nucleus of an atom. So here are their definitions: the mass number and the proton number. You can even write them down. So now here what are we going to do next is that we have to our task is to identify the proton number and the atomic number of the elements in the periodic table. Like for example, we take here our element as H, hydrogen. H for hydrogen. We take hydrogen, and you can see that its atomic number and the proton number in the periodic table is written as 1 1. So it's too easy for you to identify that its proton number is the down one or the smaller one. Here both are 1. I will tell you why. You can simply identify that its proton number is 1 and electron number is equal to the proton number, so it is also 1. Remember that electron number is the number of electrons present inside an element is always equal to the proton number. If the element is not charged, it is just neutral. Otherwise, if it's charged or it has gained or lost some electrons, so then you can say that proton number is not equal to electron number. If the proton number if the atom is neutral, it is not charged, it is just neutral, it doesn't have any charge, so then you say that proton number is equal to the electron number. So here whatever we take from the periodic table directly, we must consider them as neutral, and so their proton number is always equal to the number of electrons. So you can see that its proton number is 1, and so electron number is also 1. However, the neutron number, you see that its neutron number is also 1. What is the neutron number? You can see that its nucleon number or mass number is 1. So here the mass number or the nucleon number, you know that it is the sum of protons and neutrons present inside the nucleus, sum of protons and neutrons. So when you see that proton number is already 1, so, and the mass number is also 1. So what does it means? That the mass number, which is actually 1, if you take out the proton number, which is 1, in order to find out only the neutron number, you get 1 minus 1 is equal to 0. This means that your neutron number is 0, because the mass number is the sum of neutron and proton number. When the proton number is 1, so, and the mass number is also 1, so if you subtract 1 from if you subtract 1 from 1, you get a 0. That means that your neutron number is 0. Now you guys must be thinking, so why don't we consider neutron number as 1 and proton number as 0? Because you you can see that the here proton number is atomic number is already 1, so you just extract that atomic number and consider the proton number in that element to be 1. So so when our proton number is already 1, we will subtract this one from the mass number, which is also 1, so here we get neutron number as 0. Likewise, if we do for boron, which is B511, we know that the smaller number is the atomic number, and it tells us about the proton number. So its proton numbers are 5, and proton number are equal to the electron number, so they are also 5. And here its mass number is 11, so we know that the mass number is the sum of proton and neutron. So in order to get only the number of neutrons, we will subtract this mass number from the atomic number, and we'll get our neutron number, and we'll get the neutrons, the number of neutrons left behind, which comes out to be 11 minus 5 is equal to 6. Same for neon, Ne1020. Proton number, you can see 10. Proton number is equal to electron number 10. Neutron number 20 minus 10 is equal to 10 is the neutron number. Then for phosphorus, and 1531, proton number 15 is equal to electron number, and then mass number minus the atomic number, you get 16 as your neutron number. And then Ca calcium, 20 40 20, proton number is equal to electron number 20, and then 40 minus 20 to get the neutron number, which is 20. So this is the method to find out the number of electron, proton and neutron present in a certain element of the periodic table.